Every modern system relies on digital certificates. Most outages and breaches don't come from broken cryptography. They come from managing those certificates badly. In this module, you'll see how to control requests, issuance, renewal, and revocation, so your enterprise trust fabric stays reliable, predictable, and up all the time. Treat certificate management as a continuous loop, not a one-time task. You start by generating keys, ideally inside an HSM, and creating a CSR. An enrollment step then verifies identity before the CA issues the certificate, and it's deployed, often automatically, to servers or devices. From there, monitoring takes over, tracking expiry, configuration drift, and policy compliance. Before certificates expire, they're renewed or rekeyed. And if anything is compromised or no longer authorized, revocation immediately removes trust. For key pairs in PKI, the golden rule is non-negotiable. The private key never leaves its safe home. Whether it lives in software on an endpoint, inside a TPM or secure enclave, or in a centralized HSM, the pattern is the same. The key pair is generated locally, the private key stays protected, and only the public key goes to the CA inside a certificate request. If you're ever exporting private keys in plain text, you're breaking basic PKI design and increasing your attack surface. A certificate signing request is essentially an X-ray of the certificate you want. It carries identity, the subject DN, which is your structured name, and the SANs, which are the DNS names, IPs, or UPNs clients will actually connect to. It also embeds the public key that the CA will certify, and it's signed with the requester's private key, proving possession of that key. What's not in there is the private key itself. A CSR is safe to share. It's a verifiable public request, not a secret. Enrollment is about choosing the right way to get certificates where they need to go, balancing automation, modern protocols, and platform coverage. Manual enrollment has almost no automation and works for one-off certificates or highly protected offline routes, but it does not scale. SCEP added automation for network gear and older MDM, but uses older HTTP patterns and has design limitations. EST brings modern TLS, stronger security, and scales well for contemporary infrastructure and IoT. Windows auto-enrollment is highly automated, but mainly serves domain-joined Windows endpoints. Automated issuance is the engine that turns a CSR into a trusted certificate without human bottlenecks. First, identity is verified. Does the request really come from the system or person it claims, using directory data or out-of-band checks? Next, policy is enforced. Key size, key usages, and EKUs must match what your PKI allows. Only then does the CA approve and sign with its private key. As certificate lifetimes shrink from years to 90 days and less, this automated pipeline becomes essential infrastructure, not a convenience. Renewal and rekey solve related but different problems. Renewal says, this key is still good, just extend the certificate. You reuse the same key pair, risk stays about the same, and effort is minimal, ideal for routine expirations. Rekey says, give me fresh key material. You generate a new key pair, shortening the time any single key is exposed. It's more work, but it's the right choice for planned key rotation, algorithm deprecation, or any suspicion of compromise. Zero downtime rollover is all about planned overlap. You don't wait until a certificate is about to expire. You issue the replacement well before the not after date. During that overlap window, both certificates are valid. You then deploy the new certificate to a subset of traffic first, using blue, green, or canary techniques on your load balancers. If something breaks, you immediately roll back to the old cert. Once monitoring and client behavior look clean, you finish the cutover and let the old certificate quietly expire. Revocation is PKI's emergency brake. You use it when continuing to trust a certificate would be worse than breaking something. If a private key is exposed, you must assume an attacker can impersonate that identity. If a CA is compromised, everything it issued becomes questionable. You also revoke for process issues, like misissuance or policy violations, and for normal lifecycle reasons, systems decommissioned, ownership or roles changing, or migrations that replace a certificate ahead of schedule. CSRs and OCSP answer the same question. Is this certificate still valid, but with different trade-offs? With CRLs, clients periodically download a signed list of revoked serial numbers. That's simple, easy to cache, and doesn't need per-connection lookups, but it uses more bandwidth and can be stale until the next refresh. Oax's Pay is interactive. The client asks, "Is this specific certificate good right now?" and gets a signed answer. That's near real-time and lighter on bandwidth, but it adds responder availability risks and raises privacy concerns because the responder sees who you're checking. When a client receives a certificate, it effectively walks through 3 checks. First, is the certificate within its validity period? If it's expired, the client must hard fail and drop the connection. Second, assuming the dates are fine, has it been explicitly revoked via CRL or OCSP? A revoked certificate is another hard failure. The tricky case is when revocation checks timeout or are unreachable. At that point, client policy decides fail open and risk trusting something bad, or fail closed and risk impacting availability. At this stage, think of PKI as a precision engine continuously issuing and refreshing identities across your entire stack. CCD pipelines need short-lived certificates for each deployment. Service meshes require MTLS identities for every microservice. MDM or UEM platforms must provision device certificates to laptops and mobiles. Load balancers and WAFs rely on Acme automation for web TLS. Trying to do this by hand doesn't scale. You need orchestrators and standard protocols to push and pull certificates everywhere, automatically and safely. Picture your enterprise PKI and auto-enrollment engine as the core machinery and governance as the rails that keep it aligned. Issuing policies define who can get which types of certificates and what identity proof they must provide. Lifecycle rules enforce maximum validity, approved algorithms, and key sizes, so nothing quietly drifts out of policy. Clear roles ensure no one person can request, approve, and audit the same certificate stream. And continuous monitoring of issuance, revocation, and failures closes the loop. Technology runs the system. Governance keeps it trustworthy at scale.